Hi, I'm Isabel, and I'm here with David, Olivia, and Annie, and today we're going to talk about our E80 sensor project, which dealt with determining the relationship between temperature, humidity, carbon dioxide, and volatile organic compound concentrations. A quick overview of our presentation, we're going to give an introduction into air quality and then describe our design process, sensor selection, and calibration and modeling. From there, we'll discuss our data and findings and its implications on future experiments. In the US, the standard way to measure air quality that's used by the EPA is with an air quality index. The air quality index is a number from 1 to 500 describing an environment. Lower than 50 is good air quality, and above 300 is hazardous and unsafe to breathe. AQI relies on quantitative data in 5 categories: ground level ozone, particulate matter, carbon monoxide, sulfur dioxide, and nitrogen dioxide. Each category has their own number, as shown by the picture and example for particulate matter, and then is factored into a greater AQI. So we used AQI as our inspiration for measuring air quality, but we didn't have the resources to test for everything that was required, so instead we tested for TVOCs and ECO2. TVOC stands for total volatile organic compounds, and they're chemicals that are released into the air from the manufacturing or use of everyday materials, such as aerosol sprays, cleaning chemicals, and children's toys, and a lot of other things that are in our everyday lives. They can cause serious health effects and even cancer and liver failure, so they're very dangerous to us. These factor mainly into indoor air quality, which has actually been proven to be about 5 times more polluted than outdoor air. Since 90% of our time is spent indoors, this seemed like a good way to measure something that could potentially greatly affect us. We also measured CO2 levels. CO2 is not technically classified by the EPA as a pollutant because it is naturally produced by living things. However, it is an extremely harmful greenhouse gas and the primary cause of climate change. It can also be indicative of other pollutants, so it's a feasible measure for pollution.
According to an outside study, temperature and humidity affect perceived air quality in a given environment. We wanted to test whether these perceptions matched up to reality. We expected increasing temperature and humidity would increase readings of ECO2 and TVOCs.
We measured temperature, humidity, and air quality using a thermistor, a humidity and temperature sensor, and an air quality sensor that measured CO2 and total volatile organic compound concentrations. We wanted to collect data both indoors and outdoors to see if there was any discernible difference in air quality. Our outdoor data points were collected every half hour during the day. Weather causes natural temperature and humidity variation, and we wanted to take advantage of that, but we were unable to log continuous data due to budget constraints. We also designed a protective box and included a fan for air intake so that the air was constantly filtering through the box. And our indoor data points were collected in different rooms at a variety of temperatures.
Circuit shows the 3 sensors that we have. The first sensor is the thermistor. So a thermistor varies resistance as temperature changes. So because the Arduino cannot directly measure resistance, we had to create a voltage divider. And then we converted the voltage measured off the voltage divider and converted it back into the resistance. The second sensor was a humidity sensor, and that used a digital output, so that went to one of the digital pins of the Arduino. The other pins were input voltage and ground. And the third sensor was a CS211 TVOC and CO2 sensor, which uses an I2C input, so those went to the SCL and SDA pins of the Arduino. The thermistor resistance value varies with temperature according to the Steinhart-Hart equation. However, we did not find the datasheet, so instead, we calibrated the thermistors using a logarithmic fit based off data points collected from cups of water with known temperature. Additionally, we modeled the thermistor to ensure the voltage would not exceed 3.3 volts, as seen in this equation here, given the value of our second resistor and the expected output of the thermistor. Additionally, we calibrated our humidity sensors using fridge and sour steam to ensure that it varied with humidity.
To process the data, we simply recorded readings periodically from our serial monitor onto a spreadsheet. We can see the resulting plots here. The dependent variables here are the pollutants, ECO2 and TVOCs. Independent variables are the temperature and the humidity. The readings from the thermistor and DHT sensor are accurate to about 5%. Gas sensor spec for accuracy was not found, but a similar metal oxide sensor has accuracy to about 15%. The top 4 plots are outdoor data, and the bottom 4 are indoor data. Overall, there was not enough evidence to confirm our hypothesis. The data shows a very weak correlation between temperature and air quality, and basically no correlation between humidity and pollutant levels. Indoor pollutant levels, however, were significantly higher than the outdoor. Fresh paint also seems to have an effect on indoor air quality, thereby diminishing indoor air quality. The strongest relationship we found was between temperature and TVOCs, but it was still pretty weak with a correlation factor of about 0.3.
Now I'd like to talk about the implications of our work on society. Although no correlation between temperature, humidity, and air quality was found in our study, it doesn't mean that there is no correlation. Reasons that we may have not found a correlation maybe due to the fact that temperature and humidity were not tested independently from one another. And there were some direct influences on human activity on the air quality that we recorded, such as what you can see in the graph below. In addition, we did find that there were regional differences in baseline air quality, and that indoor air quality was indeed poorer than outdoor air quality as expected. This suggests that people with sensitivities to air pollution may have better health living in a region with higher baseline air quality or who spend more time in the outdoors. If this experiment were to be conducted in the future, we would recommend that an individual hooks up their air quality sensor to the 3.3 volt Arduino pin rather than the 5 volt to avoid computer noise. Additionally, we would like to implement continuous data logging in the future so that we were able to log data overnight and also day to day to see if there are daily changes in baseline air quality. We'd also like to test temperature and humidity independent from one another, and we would have benefited from the use of more sensors that would have given us a more comprehensive view of air quality.
We'd like to thank the E80 teaching team for their help and guidance during this experiment.